Hey Lena, hey Chuck, Mr. I-Bling. Hope you're having fun today. We are. We're going to do some neuromuscular junction action. Alright? Sweet, so hopefully you get to see this. Alright. Well, make sure I don't put my water bottle. Just let me know if I put my water bottle in front of your video, okay? Just yell at me. Okay. Just to summarize, we're learning about a neuromuscular junction. Basically, it's where the brain sends a signal through the nerve, the spinal cord, and then it arrives at the muscle. So we're going to learn what happens right here. Right? Okay. Alrighty. So, we've got our nerve cell. And it looks like a crazy, it's called a dendrite. And here's our axon. And then we got the end of our axon, we've got our, we call the end of the axon.
The terminal.
Axon, terminal. Right? Yep. So our axon, terminal. It's the end of the nerve cell. Terminal. Right? Then, every skeletal muscle needs to have nerve cells that, I don't want to use the word attach, because that implies that this nerve cell is going to directly attach to the muscle cell. But it's not. We've got a muscle cell. Okay? Here's our muscle fiber. Muscle fiber. Okay? All right. It's not attached. How is the signal going to get from the axon, from the brain? So our brain, okay, there's a bunch of these. You have nerve, you got your, oh no, I made a nerve in red muscle, no, terminal, okay, then nerve, alright. How is the signal going to get to the muscle if there's a gap?
Mr. I-Bling, you just died. You just stopped moving. It's the end. The body is flawed.
I don't think that's what happens.
No, right? Obviously, the human machine has been perfected, okay, for hundreds of millions of years. This is a flaw that would not stick around. All right, so how are we going to fix this?
We're going to figure out something to make it work.
How are we going to make it work? You guys engineer it real fast.
We're going to build a bridge.
So, okay, so the nerve cell builds a bridge, sends out some like osteoblast type things, and build a little bridge. Right. Well, wouldn't your bridge already be there? If it did that? Is it going to build a bridge every time we want to contract?
Too much work.
Too much work, I agree. Right. What do we got to do? Right.
So,
With what?
So we're trying to figure out how this axon terminal is not going to be terminal if we want to get the signal to the muscle fibers.
The signal's got to get to the muscle fiber to contract, right?
Yeah.
So would it make sense that the muscle fiber is attached to the nerve cell?
Yeah.
Yeah, but it's not. So something's got to
I
happen.
have a problem.
Right? We've got a problem. What's going to happen is it's going to send out a chemical messenger. Okay? It's going to send out a chemical messenger. And these chemical messengers, anyone know maybe a fancy name for a chemical messenger?
Neuron, yep.
Neurotransmitter. So it's going to transmit a nerve signal. Okay? I'm going to abbreviate it, neurotransmitter. Okay? So it's going to send out a chemical signal called a neurotransmitter. It's going to arrive at this muscle, and that's going to act like a hormone. Okay? Like when a hormone binds your cell, it tells your body, your cell to do something. Like when insulin binds to your cells, it says, open up cell membrane, we got some sugar to bring in. Okay? When testosterone arrives at a cell, it says, okay, maybe we're going to build muscle. Okay? That's what testosterone will do. We're going to create production. So we're going to release a neurotransmitter here. So it's going to send its signal, and it's create what's going to call action potential. And it should be a vocab word that's in your sheet. The flood of positive ions into the fiber generates an electric charge, an action potential. Okay, so we're going to separate an action potential. And then when this action potential reaches the terminal, that's going to be its signal to release What color should I make them?
Blue.
Ooh.
I like the color blue.
Okay, so they're going to be stored from neurotransmitters here. Okay, so my blues are going to be my neurotransmitter, but there's a lot of neurotransmitters in your brain. Some of the more common ones you might have heard is one called like serotonin.
Yeah.
And serotonin is one that makes you feel good. Okay, that's a neurotransmitter. When serotonin is high, you generally feel good. I take a neurotransmitter called every night called GABA, G-A-B-A. Some people might have heard of it. It's kind of common. You can go to Walgreens and maybe buy some. It's an inhibitor. It relaxes me at night. So when I take some GABA, a half hour later, okay, my brain stops receiving signals. Well, when your brain's receiving a lot of signals, is it easy to fall asleep?
No.
Your brain's like, signal! Ah!
Remember that one time you were telling us
Gosh.
about you took your
Oh.
Took your energy ones?
Oh.
Yeah.
That was the worst. I remember that day. Yeah, I got up and, because I would...
You take your protein shakes like 2 in the morning. You actually took your pre-workout.
Yeah, I had my protein shake and my energy mix, because I would, when you work out at 5 in the morning, things got to happen fast. So yeah, I woke up and to take my protein shake, so I built some protein at night, right? And then I woke up and I took the energy mix instead. And then I sat down, and like 15 minutes later, I'm like, what's going on? And I'm like, and it's like 2 in the morning, and it was awful. It was terrible. I eventually fell asleep, but no, my neurotransmitters were firing like crazy. Okay, so we've got our storage of blue neurotransmitters. We got a name for these guys, and I gotta spell it. We can spell it. Acetylcholine. Oh, that was bad. Because it's just acetyl and a choline. Those are words I use a lot. Acetylcholine. Or we're going to abbreviate as ACH. ACH. So when this action potential gets to the terminal, okay, it's going to release ACH. And they're going to float around like little buggers. Okay, now, what's going to be on the outside of our muscle cells is going to be very important for this process to work.
Receptors.
Yeah, A+. Candy.
Oh my gosh.
Yeah, that's a good one. That's from first semester. A cell doesn't know it needs to do anything. And Caitlin, this will, because obviously first semester, she's like, I wasn't here, oh no. So on each cell, Caitlin, did you guys do cells in your class?
No.
Just curious, what do you guys generally go over?
We went over like basic stuff that we should.
What?
Throw some vocab at me. Put you on the spot.
Independent variables.
Oh, remember those?
All right.
Independent variables?
No. Why isn't she in bio? I'm confused.
They felt she was so awesome that,
Do you
yeah.
like this class?
Yeah.
That
No.
was exciting, yes.
Yeah.
I like
My
the
guess
bio.
is her class was probably called something other than biology.
Yeah, it was called math.
Anatomy and physiology. We learned about independent variables, so I don't know, I don't know what's going on there.
Takes me back to a good
That tells me it may not have been a very good class. Not to blast your other teacher, but normally when a student comes to me from another class and they can't tell me anything they learned about, either this student wasn't paying attention, and obviously she pays attention, right? She
Yeah.
works.
Yeah.
So probably wasn't all that great. So I'm glad you came here. You're going to learn a lot more about science. And
And I like
we saved her. We science saved her.
Like this is the first science I've actually done really good,
Yeah.
and I actually like it
Me
a
too.
lot.
It's
Like,
good, yeah.
It's my favorite class.
What happens actually is people come in as freshmen. They don't really know what science is. Okay, and then especially with females, there's a lot of studies done with females in science. Females are very intimidated with science.
Yeah.
They have a very inferiority complex when it comes to science. They get discouraged very easily.
Like with chem and physics. Like I was
Yeah.
really bad at physics.
It's something to do. I went to a seminar. Girls do well on positive feedback. Okay, they're usually good students, right? They're meticulous. They do all their work more than boys. Who are a little more sloppy and they forget their homework a lot. They turn something in, they get their answers right, and they get a smiley face. Okay, girls generally respond well to that. They're conditioned. But in science, science is, here's a concept you might not understand, okay, and then they don't get that because they're not right all the time. Okay? They're wrong a lot, and they're not used to being wrong and not getting the smiley face. So, glad we could break that down. Okay? Myself and Mr. Wimber have been working very hard to get you guys comfortable with being wrong, and then learning how to do it.
Yeah, Wimber does that a lot.
Yeah, that, like every
Yeah,
day
it's-
was
it's talking about that. Anyway, your cells have these on the ends of them. We saw these with the viruses, and okay, because your body sends messages all the time. We get into our brain unit. I really want to focus on hormones because they're so important. And every time you take a drug, if you look at all the drugs people take, America is the most drugged out country in the world. I'm not talking like street drugs. I'm talking about prescription drugs.
Yeah, and like
Everyone's on something. I'm on something.
in consumers, we learned that we, out of the whole world, we consume
The
3/4 of all the antidepressants.
antidepressants.
Of
Yeah.
the whole
Yeah.
world, 3/4. That means one
I mean-
quarter of the rest of the world is sharing your food.
I mean, Americans, for example, buys like, it's crazy. Like, we spend, look at all the commercials. You watch a football game. Every other commercial is like Viagra.
Yeah.
Or the one that, I forget
Or
what,
like-
Levitra. When
or
you
like
go to the
when
bathroom.
We would watch 60 Minutes and current events, and like every commercial was like
Viagra.
Viagra or
Yeah.
that other one.
Viagra is the best-selling drug in the country.
Really?
It prints money. Yeah. And Viagra is a hormone too. Viagra is so to talk about like a hormone and receptor. You guys know how Viagra works?
Doesn't it give, I'm not actually going to
We talked about it.
Yes.
We talked about it. No, it ties in vocab words from our class. So obviously it's for, you know, it's for allowing it to fill up with blood, right? Well, what carries blood? Your veins, okay? And okay, I can say penis in that. I mean, male penis is filled with blood vessels, and if they're vasoconstricted, will there be a lot of blood flow?
No. So
No.
then that
Volume will be very
It
small.
dilates them.
So the cells on the blood vessels, the cells of the blood vessels on the veins have receptors on them. And Viagra triggers the production, something called nitric oxide, which acts as a hormone, and it binds to the cells of the blood vessels in the male penis, and then causes it to vasodilation, okay? So that's a roundabout way of me talking about a receptor and how it causes an action in the cell. It causes vasodilation, which causes more blood flow, which causes more volume to be filled up. So, I know, I can't like, I love the flag, you know, but
Little America. I like that you have an actual flag. Other teachers have like those $1 ones from Walgreens taped to the wall.
okay. So that's how a receptor works. When a receptor is bound, a change happens. So, what is our hormone? Our messenger,
ACL.
ACH.
Oh.
I killed it. ACH. All right. And what are we going to have here? Like Courtney told us.
Is this the receptor or is this a block
Yes, it is. I just zoomed in on one cell.
Okay, so that's.
All right. So now we've obviously got these acetylcholines, okay, flooding in, and eventually an acetylcholine is going to bind to receptor. Okay, so what happens when ACH binds to a receptor? Something's going to happen, right?
Yeah.
Quite simply, what's going to happen? Without being real technical, what's our goal? To get what to happen?
To get the muscle to move.
Right, and when we say move,
Contract.
contract. So our goal is to get this muscle to get to something like this, a shortening. Okay? So how's this going to work? Well, remember how we learned about bones and it's full of calcium, and I told you that your body needs the calcium in your bloodstream more than it needs in its bones. Okay? So this is where a lot of that comes into play. Is when this is bound, it's going to release calcium. No, not red, Mr. I. Show my calcium. We got green, blue, yellow, brown,
We have
magenta.
magenta.
Yeah, I use Megan tech.
Magneton.